Okay, so hopefully in part one you've established how to convert between polar and Cartesian coordinates. We're going to talk about graphs of polar equations. Okay, when we look at a polar equation, it's going to be r as a function of theta. Okay, so I'm going to have r equals and stuff with thetas in it. It's usually that. Sometimes I get an r squared equals, but not so much on the AP exam. So I just want to talk about some logic things. What curve is represented by the polar equation r equals 2? Okay, well, what is r? Ask yourself what r is. If you need to pause to think about it, go ahead and do that. R is our distance from the pole. Okay, so if I want to have every point where the distance from the pole is 2, what would that look like? Okay, again, if you need to pause that and think on it, go ahead and pause and come back to me when you've established what all points 2 units from the pole would look like. And hopefully you came up with a circle. Okay, so I should have a circle where all the points are 2 units away from the pole. So just as a general rule, I know that if I have an equation in the form r equals a, I have a circle with radius a. Okay, moving on to the next one. I want the polar curve with theta equals 1. Now let's ask ourselves what theta represents. All right, if you need to pause to think about that, go ahead and pause it and come back to me when you know what theta represents. But theta represents our angle off the polar axis. So I want to have every point that is 1 radian off the polar axis. So I'm going to just get a line, right? Because when we looked at where theta equals pi over 3 or 7 pi over 4, we were looking at that, a line with that central angle. So, okay, so I've got a line here with central angle 1. Okay, so it's 1 radian off the axis, right? And pi over 2 is roughly 1.5, so it makes sense that I'm in quadrant 1, and then it carries over also into quadrant 3, if I could imagine the quadrants on here, because I can have positive r values in quadrant 1 or negative r values, which would take me into quadrant 3. All right, so theta equals a is going to represent a line with central angle theta. Okay, so what are we going to see frequently? We are going to see these r equals a's, r equals 2, r equals 4, r equals 3, r equals 1. We're going to see these frequently, okay? This, not so much for our purposes for what we're going to see on AP, okay? But definitely if you can remember that r equals a is a circle centered at the origin with radius a, that will be helpful to you. All right, let's look at some more. Okay, so for this example, I asked to just sketch the curve with polar equation r equals 2 cosine theta, but really what I want to do is I want to convert this to Cartesian form, okay? So looking at this equation, we're going to use our 4 formulas that we came up with in part 1 of the video. Okay, and I want to swap out my r's and thetas for x's and y's, so I need to either have an r cosine theta in the mix, so I can make it an x, or an r sine theta to make that a y, or an r squared, so I could swap it for an x squared plus a y squared, or a tangent theta, so I could swap it for a y over an x. Okay, so what I want you to do is I want you to play around with this original function and see what you can do with it to make productive things, okay? And the only productive things will be r cosine theta, r sine theta, r squared, or tangent theta. If I have a secant theta, not productive. If I have a cosine squared theta, not productive. So think about what you can do with this. Play around with it. You might get there, you might not. But pause the video, come back to me when you feel confident. So starting with r equals 2 cosine theta, I'm guessing a lot of you guys tried squaring both sides, and that's great. For the left side of the equation, we end up with an r squared, which we could swap out for an x squared plus y squared. But on the right side, having a cosine squared is not at all productive. So a better solution would be to multiply both sides by an r. And then I get an r squared on my left side, same as I would if I square it. But on the right side, I end up with an r cosine theta, which is much better. So I multiply both sides by r, and that gives me... Okay, so once I have my r squared equals 2r cosine theta, I'm ready to swap some things out. So my r squared becomes my x squared plus y squared. My r cosine theta becomes x, and we have x squared plus y squared equals 2x. That would be wonderful if we could be done with this. And if it was the AP exam, it would be fine. But we're going to go a little bit further in case we end up taking a college Calc 2 course where we have to simplify this to have it be something recognizable, because right now this is not something I would really recognize the form of to know how to graph. So I'm going to go ahead and complete the square on this. I'm going to combine all my x terms to one side. So I brought all my x terms to one side. Now what I do is I'm going to take half of this number, okay, which would be a minus 1, and I'll have x minus 1 quantity squared. Okay, so that gives me my x minus 1 squared when I take half of the minus 2, and then I go back and I square it to figure out what the missing value would be on each side, which would be my 1. Okay, so I'm going to square that up. Okay, and then the missing link would be having that plus 1 on both sides. So I take half the coefficient in front of the x, and then I square it to figure out that constant term. Okay, and the benefit to having this form of my equation is that now I recognize that this is a circle. It's centered at 1, 0, and the radius of the circle is 1, which means I can graph this now. Okay, so here's our circle, and it might be beneficial for us, and we'll observe this as we keep going through this, but if I have r equals a number times cosine theta, we end up with a circle that's centered on the x-axis, and the diameter of the circle, what's the diameter of the circle? The diameter is 2, and that happens to match the coefficient on my function. Okay, so just something to recognize as we're going through with this. Let's look at another one. Okay, I want to convert r cosine theta equals 1 into a Cartesian equation. So we're going to use our same 4 formulas. Okay, and I hope you recognize how easy this is, but if you need to pause, and you need to have either r cosine theta, r sine theta, r squared, or tangent theta to make a swap, and you're ready to go. So hopefully you've done that. Pause if you haven't, and you should come up with the equation. Since r cosine theta is really just x, I'll have x equals 1. Okay, nice and simple. Let's look at another one. Okay, so for number 8, I want to put r equals 3 sine theta in Cartesian form. So we're going to use those same 4 formulas. Okay, and this one is a lot more like number 6. So here's your chance to try out to see if you understood what we did in number 6. I want you guys to pause the video and try to make up. You want to have r cosine thetas, r sine thetas, r squareds, or tangent thetas, and that way we can get rid of our r's and our thetas and replace them with y's and x's. So go ahead, pause the video, and come back to me when you think you're ready. Okay, so starting with r equals 3 sine theta, hopefully you didn't try to square this again, but just multiplied an r in on both sides, and we end up with r squared equals 3r sine theta. Okay, now that I have an r squared and an r sine theta, I'm ready to make a swap, and I will have x squared plus y squared equals 3y. Okay, if you didn't try to complete the square, try to complete the square. Okay, I'm going to start by moving my y term with my y squared. Okay, so I'd have x squared plus y squared minus 3y equals 0. Now, to figure out when I complete the square, I'm going to take half of the minus 3 and get a minus 3 halves. Okay, so I should have an x squared plus a y minus 3 halves quantity squared, and then to figure out, so I'm taking half to get to here, and then to figure out what the constant term is at the end, I'm going to square that 3 halves. So I'm going to square it to get to here, so 3 halves squared, and because I'm adding it to 0, it's just going to get me right to that last coefficient. So 3 halves squared would give me 9/4. Okay, and the benefit of this is that I can see that I have a circle centered at, think about that for a second if you need to, but it's going to be centered at 0, 3 halves, with a radius equal to, and we have to remember that this number at the end is my r squared, so the radius would be 3 halves. Okay, and that's just a benefit for graphing. So if I were to graph this, I have my circle centered at 0, 3 halves. Okay, the radius is 3 halves. The diameter of the circle would be 3. Okay, and so now I see, and hopefully can observe a pattern, that if I have r equals a number sine theta, it's a circle that is centered on the y-axis, and the coefficient in front of the sine is going to be the diameter of the circle. All right, let's look at another one. On this one, I want to go backwards, and I want a polar equation for x equals 3. So I am going to use my same 4 formulas. Okay, and now that I'm going from Cartesian to polar, I need to have on the x and y side of this, I either need an x or a y, or an x squared plus a y squared, or a y over an x. And because I have a plain old x here, I can make a very simple substitution and have that our cosine theta would be 3. Now, if you remember before, we said that we were always going to write r as a function of theta, so I need to solve for r here. So go ahead and solve for r. Pause if you need to and come back. And all I need to do is simply divide out my cosine theta, and I should have r equals 3 over cosine theta. And this is a completely acceptable form of the answer, but if you would really like to, you can also write this as r equals 3 secant theta, okay? And I wouldn't really worry about this rewrite. However, I would just say that if you're ever converting from polar to Cartesian and you see a form with a secant in it or a cosecant in it, I would convert that to be a 1 over cosine theta so that you can see it for what's a helpful, beneficial thing. Okay, so there are our answers. Let's look at another one. Okay, I have an x squared plus a y squared equals 9. We're going to go from Cartesian to polar, so we use our same 4 formulas. And again, when we're trying to go from x's and y's to r's, we need to either have a plain old x, a plain old y, an x squared plus a y squared, or a y over x. And this one's much easier than you think it is. So pause it and figure out my equation. All right, and what you should have done is that my x squared plus my y squared is simply my r squared. So instead of having x squared plus y squared equals 9, I should have r squared equals 9, and I need to solve for r. Okay, and if I do that, I'm guessing that you've come up with r equals 3. Okay, now unfortunately this is not the all of it, so think about what's missing if this is all you have, and pause it and come back when you've figured out what's missing. But what's missing is r equals negative 3. Okay, so when I take the square root, I need plus or minus those values. All right, let's just talk about why this makes sense. What is this? This is an equation of a circle centered at the origin with radius 3. Okay, what does this describe? We talked about this. R equals a number describes all points 3 units from the pole, which means a circle with radius 3. What does this describe? This describes all points negative 3 units from the pole. And what did we say negative r values meant? It meant that you were going on the opposite side of the pole, which is still 3 units from the pole. So both of these, r equals 3 and r equals negative 3, both describe a circle centered at the origin, centered at the pole, with radius 3. Okay, that's it for converting our equations.